Hello and welcome once again to the Maths Jedi channel. This is the fourth video, I think, in the A-level series. This particular video will be focused in on binomial cumulative distribution functions, particularly using a calculator to do binomial cumulative distribution functions. If you've tuned into other videos on the channel, you would have seen on this particular playlist, we did discrete random variables the other day. There was a video on binomial distributions and also a video on using tables to do binomial calculations. So I would check those out before you carry on with this. Hopefully today, after today's lesson, you'll be able to use a calculator really well to do binomial cumulative distribution functions. That's the purpose of this particular video. I will go through some specific questions with you, some for you to try as well in your own time, hopefully that you can do at home. So just really focusing in on specific examples and questions, looking at some of those catchy things that you might get under exam conditions. If you're new to the channel, please do leave a like or subscribe. I'd appreciate that a ton. It would be really helpful for me to get that happening on my channel, and I can see many of you are doing that, so I appreciate all the support that you're giving me. So without further ado, let's just have a look at some questions and really focus in on using the calculator. The calculator I'm using today is a Casio calculator, so I'll just show you that real quick. It's this particular calculator here, which is an FX570991EX. You can get them on eBay relatively cheaply. Your school might be helping you to buy these at a relatively cheap rate. I would recommend these or the CG50, which is the graphical calculator, the one next up from this. CG50s can be around £70 to £100. These ones are more like £20 to £30. So you really take your pick on what you want to do. If you learn to use these well, these are very, very functional calculators. You can use them at A level. They're all exam compliant, so don't worry about that. They're all equally usable and very functional to use. So I'd definitely have a look at those. No, question 7 was the first one we're going to start with here then. And this is on page 95 of the textbook if you have it. We're going to look in on this question and just have a look at this and make sure we're using our calculator to do this properly. So this is talking about a discrete random variable. It's a binomial distribution. It's the parameters here are 30 and 0.73. So n is not 30 and probability of success 0.73. And we're being asked for the probability of it being exactly equal to 20. So I'm going to show you how to use a calculator to do that. And we're going to just carry on through this process, just seeing how to use a calculator to do these difficult things. You'll remember from my previous video, I was showing you how to use the tables at the back of the exam formula sheet. Unfortunately, there'll be some questions that you'll come across which tables can't be used for. And this is an example of that. You won't be able to find this particular example in the tables. So that's where the use of a calculator is pretty essential. So we're going to get our calculator up here. We're going to look at the modes. So first of all, if you press the menu button, you'll see you'll get different modes. So this is the mode that you're mostly in, which is calculate mode. The mode we need to be working in today is this mode here. You get to there, navigate to there with the side arrows and the down arrows, and you can see it's called mode 7, distribution. So we're going to press the equals button and go on ahead and get into the distribution function mode. When you do that, you'll get 4 different choices. So we're going to focus in on the binomial distribution. It's not this one you need because it's not the probability density function you need. It's this one you need. So it's binomial cumulative distribution function. So binomial CD. I'll just show you how I got that again. I pressed this particular button here and I got binomial CD. So it's binomial cumulative distribution function. So we're going to press 1. And then you get 2 choices. You get list or variable. I will show you how both work, but I'll show you mostly how variable works because that's the mode you'll use most of all. Number 2. I will show you mode 1 as well, but mode 2 is the one you'll use most of all. So I'll go ahead, press 2, and you can see you get a set of functions here to put in your different parameters. So in this particular question, you can see n here is going to be x here is 20 because we're looking for exactly 20. So we're going to put in 20 and press equals. N here is 30, so we're going to put 30 in for n. And then the probability here is 0.73. Now, what you have to recognize is this is the binomial cumulative distribution function. So this is going to show me the probability of those numbers less than or equal to 20. So this probability here is not equal to 20. This is the probability of less than or equal to 20. I'll just get the pen up and show you that working so that we can actually see that functioning. So this here is going to be the probability of x less than or equal to 20, and that's 0.27555. Okay, we'll do it to several decimal places here, just get that looking a bit neater. So 27555. So with these, if you go to 1, 2, 3, 4, 5 decimal places ought to be enough. If you give your answer as 4 decimal places, if you start with 5 and then give your answer as 4 decimal places, you'll stay hopefully within the parameters that you need to do. Most questions ask you for three SFs, so 4 SFs ought to be plenty. You'll need to look at the questions for each individual guidance or look at the front of the exam. Most of the time they say 3 SFs is enough, 4 SFs is plenty, so you just need to look at the question. Now, as I mentioned, this is the probability of it being less than or equal to 20. So to get the probability of it being exactly 20, because that's what we need, exactly 20, we've got to do the probability of less than or equal to 19 as well. Okay, so we'll look at probability of x being less than or equal to 19. So I'm going to go back to my calculator. I'm going to just get my arrow key so I can press the calculator. So back into there, and then this time we're going to change this to 19. So we're going to change that to 19. You can see me changing it there, press equals, and still 30, still 0.73, and this time I get a different probability, so it's going to be 0.161. I'm just going to move this slightly because it's just in the wrong place for me. So let's make it slightly easier to use it. So 0.061297, that ought to be plenty. I've done 6 there just to avoid any rounding. So these are the two probabilities, so 20 and 19. Now to get exactly 20, I need to do this probability, take away that probability, don't I? So I'm going to do 0.27555, take away 0.161297. Now I'm going to do that, not in this mode, because this is the wrong mode for me. I'm in binomial CD mode at the moment. I need to go back to calculate mode. So I'm going to go back into mode 1. This is back into calculate mode. And then I'm going to do 0.27555. Take away. I can use the answer button. It will remember this number from before. So that gives me an answer. And that's going to be 0.114. So again, just to be really safe, I'm going to stay at 3 SFs because that will be perfectly safe as an answer. So 0.114. Should be the answer. Let's just double check that, make sure we're okay. So here is the answer scheme. I'll just move this out of the way slightly. So you can see here are the answer schemes. This is number 7. You can see 0.114 here. That's the answer, so that's fine. We're on track for the right answers and the right marks. So just move this back slightly. Okay. So we're going to move on to another question, part B now. So I'm going to just blank this off and clear my annotations and get to part B. So part B is saying it wants the probability of it being less than or equal to 13. Well, that's again quite straightforward on the calculator now because we've got the cumulative distribution functions laid up. I'm going to look at that this time. So we're going to get myself back to the calculator. So here's the calculator here, just move it to one side. And we're going to just put in, again, mode 7. So mode 7. We're going to do the same thing again, going to go down, binomial CD function, press 1, press 2, and here we are back to get back at the same screen again. So this time I'm being asked for 13. The number n is 30. And probability is 0.73. And you can see it's a very small probability. It's 0.0005. So 0.0005799, and I'll stop there. So 0.000579, very small. Again, just double check that that's agreeing with the answer. So you can see it here, 0.000580. They've done it to 3 SFs. So yeah, that's fine. That's the same answer as I was getting. So absolutely safe, not a problem. Right, part C now, and we're into looking at this particular question here. So this is asking for probability of x between 11 and 25. You can see it's a strict inequality this time. So we're being asked specifically for all the values that are between 11 and 25, but not including 11. So I think in the previous video you saw some examples of this being a normal inequality. This time, because it's a strict inequality, we are going to have to be a little bit more careful about what we do. So we have to just think about how these values square off. So if you think about all the values between 11 and 25, so it's 11, 12, all the way up to 25, so 23, 24, 25, we're being asked for everything but not including 11 or less. So all the values that are 11 or less are not included. Everything between 12 and 25 is what we need. So if you think about how that works for a cumulative distribution function, we're being asked for the cumulative distribution of everything less than or equal to 25, but then you've got to take away everything that's 11 or less. So everything that's less than or equal to 11. Now, I've pulled the calculators here, and this time we're going to use a new function on the calculator. We're going to use that other mode on the function on the calculator, the list function. So this time, I'm going to just reset my calculator slightly, and I'm going to just work my way through and understand how to calculate through with my new function. But this time I'm going to use the list function. So we're still going to go into mode 7. We're still going to go into binomial CD. But this time I'm going to use the list function, mode 1. So this is just showing you another version of that same parameters that you could do earlier. This time it's a table view. You can see here that it's slightly differently set out. You can see there's x at the top and probability here. We're going to put in our two probabilities here. We want 25 and I want 11. Those are the two different probabilities that I want. I'm going to make sure that I have the right binomial distribution here. So I'm going to press equals once again. I'm just going to double check that my variables are correct, 30 and 0.73. You can change them in there if you want. And then I'm going to press equals once again. And if I go back into that, you can see there, it gives me the probabilities, it writes them out for me longhand. So it's 0.9373 and then 0.00003. You can see those two probabilities there. You can see they're written out for you. So actually now you can use the calculator to list out your values. It's slightly better because you can get them all in one screen. So that way, when you're taking them away, it's slightly easier to do. Of course, you would need to show you're working. So I would want to see that you're writing down a 0.9373. And then you've got to take away your 0.00033. Okay, that's what you'd have to do. So you would have to make sure that you've got that really understood, and just to make sure you've got that value there. Yeah, so then you'd have to do those things taking away. So I'm going to go back into my calculate mode. So menu, calculate mode, mode 1, and I'm going to do 0.9373. And you're going to take away that very, very small number. Of course, it's going to be very, very small. So it will make hardly any difference. And you get this answer, 0.9373. So it's very similar to what we actually had originally. Okay, 0.9373. And again, I'm just going to double check that to make sure I'm right. So I just move that to one side. I clear my annotations, and you can see that's what they're doing here. There is one small thing, which is that they give the answer to 3 significant figures just to be safe. And you can see there's a 0.00033, the very small number. They've written it all out. So you can either use the list or variable view. The variable view will give you this value, but you can use the list view to actually sort of see it all in one screen. It's slightly easier, cuts your work down a little bit, and shows you a little bit more about what the calculator can do. So we're going to go on ahead now and look at number 8, because that's the next question in this exercise. That's on page 96. So I'm going to move my pen just to one side, and then we're going to have a look at page 96. So that should be under here, if the magic of computers works. There we go. There's number 8. So number 8 is a good example of a problem which can be modelled using a binomial distribution, but under certain conditions. So this goes back to my very second video that I did in this series on binomials, talking about those different conditions and how they operate. So we're going to talk about that for part B. Part A is quite straightforward, but part B we're definitely going to talk about how we model using a binomial distribution. So this is talking about a coin. It's biased so that the probability of a head is 2/3. The coin is tossed repeatedly. It's asking me for the probability that the first tail, notice it's a tail, not a head, will occur on the 6th toss. The 6th toss. So we've got to think about getting a head 5 times in a row. So that's 2/3. Five times in a row, so it's power 5. And then we need to get the tail. So it's 1/3 of that. And then you can use your calculator to work that out. So I'm going to do that right away. You can set in calculate mode for this, of course. So I'm just going to move it to one side so I can see that happening. So I'll just press AC. I'm going to use my fraction button here. So just in case you haven't seen the fraction button, that's where it is. I'm also going to use my brackets so you can see that happening as well. So 2 and then thirds. Close the brackets. I'm going to make that, raise that to power 5. I'm going to multiply that by a third. And I get this number 32 out of 729. You can press the SD mode and get that as a fraction or a decimal, so you can interchange between them both if you want, so 0.044 or 32 out of 729. I prefer the fraction, to be honest, because it's slightly better to write something that's accurate rather than writing something that had to be rounded, so I'm going to leave it at that for now. Part B is where you start talking about the conditions for a binomial distribution, because it says in the first 8 tosses there will be exactly 2 tails. Now it's important to get things in context here. If you go back to those conditions for a binomial, first of all, do we have a fixed probability? Yes, we do, except here tails is 1/3, of course. Do we have a fixed number of trials? Yes, we do. Are events independent? Does one coin toss affect another coin toss? Well, no, it shouldn't, so it is independent. And then finally, does the probability change? Well, hopefully not. The probability should stay the same. So all the conditions are fixed for a binomial here. So definitely easy to model it as a binomial. You will need to define what x is. So x here in this particular example is the number of tails that you're going to get. So you do have to define that to the examiner to show that you are approximating it to a binomial, and then you'll have to show what that binomial is. Now this case, it's a binomial distribution of fixed trials 8, and then the number of success, the probability of success is 1/3. It's a tail that you want, so it's 1/3, and we want exactly 2 tails. So what you're being asked for is a probability of x being 2. So this being the case, we're going to look at how's that work. It's 8 choose 2, and then the probability of success, so 1/3 to the power of 2. And then, of course, you'll have heads the rest of the time, so 2/3 to the power probability of a 6. So you're going to use your calculator to work all of that out. 8 choose 2, 1/3 squared, and then 2/3 to the power 6. And when you use your calculator to work that all out, and I did this earlier, so I've written it down, it's 0.273. And so that will be the answer for this. So our two answers are 32 out of 729 and then 0.273. We'll just go through and check that out. So let's just destroy the annotations. So here's number 8 under here. So there's number 8. So first of all, 32 out of 729, that's fine. And then going through, it's 0.273, and that's what we got. So again, just checking through the answers, but that's fine. That gives us a good understanding that we're correct and fine for that. So it's this one here we're going to look at. So a manufacturer who's planting some, or making some plastic chairs, and it is known from previous records that 15% of these chairs are green. A random sample of 10 chairs is taken. Define a suitable distribution to model a number of green chairs. So again, those conditions being tested, got a fixed number of trials, independent events, probability fixed, never changes. It should be, of course, a binomial. What binomial distribution would it be? It would be a binomial distribution of fixed trials 10, because a sample of 10, and then you've got 0.15 as your probability of success. Of course, in this example, the variable here is the number of green chairs, so you're just stating that through, making sure that the examiners can see you working through that, and then make sure you always state that X is the number of green chairs. Excuse my writing, it's quite tough to write on these things. Number of green chairs. Oops, yeah, struggle to write, I'll be honest, but this try my best to write this out as best as I can. And it says find the probability of at least 5 green chairs in this example. So we're being asked for at least 5, so X is more than 5. Well, if you remember the earlier video, you'll know that's 1 minus the probability of being less than 5, and that will be the same as the probability of being less than or equal to 4. So again, you can do this on the tables or in the calculator. I'm going to try and use the calculator today as much as possible so you can see me using it on the calculator. So again, our friend mode 7, our friend binomial distribution number 1. We're going to use the variable mode this time. I want to get the chances of it being less than or equal to 4. So I'm going to put 4 in here. I'm going to put my number as 10. And my probability is 0.15. Press the equals button. And 0.9901 is what I get. So I want to work out 1 minus 0.9901. Put the whole thing in just to avoid any rounding error. And again, I'm going to go back into calculate mode, mode 1. It will remember, so I can do 1 minus the answer, and then it gives me my answer. I need to get my pen up, just make sure I don't make that mistake again. So 0.0099, and that'll be fine. You can do 987 if you want, but to be honest, I think this is fine. So that is perfectly acceptable as an answer, and I think that'll be fine. Let's just double check to make sure we're right. So I just need to come out of there, just shrink the calculator down for a second, get this up, 0.99, so we were on number 13. So let's just find number 13. And here we are, 0.0099. They use the tables, but we've used the calculator and we still get the same answer, so I'm happy with that. Right, let's just clear my annotations. Okay, question 13, part C, sorry. Find the probability of exactly 2 green chairs. So you do need to do some thinking for this. We're being asked the probability of exactly 2. So we're being asked for exactly 2. And we know from the last video that's going to be the probability of it being less than or equal to 2. Take away the probability of it being less than or equal to 1. So we're going to look at those 2 probabilities and take them away. And much like the last question, we're going to use the list mode on the calculator for this. So I'm going to pull the calculator up, and I've got the list mode already started. So just to show you how I got there, again, just to remind you, it's mode 7, binomial CD, list mode. We're going to put in these 2 probabilities 2 and 1, 2, and then 1. We're going to make sure we have the right distribution. So our number was 10, probability was 0.15. Press equals, and you can see we get 0.8201 and we get 0.542. So we're going to just note those down, 8201 and then 0.5442. Okay, just going to come out of the calculator into calculate mode. We can do those two things, take away each other. And we get 0.2759. To be extra safe, we're going to put 0.276 just to be 3 SFs, because we don't want to have any rounding error, and I can put in brackets here, calculated or something, so they know where I got it from if you want to. Okay, so 0.276, but you can write calculator down if you want. If you use tables, you write tables. Just going to double check the answer, clear my annotations. And you can see, yeah, here's the answer here, so 0.8202. Slightly different values you can see, but we still get the same answer at the end, 0.276 to 3 SFs. And I think that's fine. Just stay within a certain margin of error. You'll always be right, and don't worry about that. Okay, so that's question 13. We're also going to do number 14. And so we're being asked for fewer than 12. And so this time we're being asked for those that are fewer than 12. Now, a reminder that fewer than 12 does not include 12. So it's those that are less than 12. So that being the case, we're being asked for probability of it being less than or equal to 11. So we need to get our calculator and look at that particular probability. We can look it up in the tables, but we're going to do it on the calculator. And here I am in binomial CD mode already. But just to show you how I got there, reminder, mode 7. Binomial CD, variable mode, number 2, we're going to put in 11, number of trials 20, probability of success 0.45. And we get 0.869. So 0.869, and that will do for that question. We're going to move on to part B now. So this is asking for exactly 12. Exactly 12. Well, that's handy that we've got this. So because this time all I just need to do is work out those that are less than or equal to 12. And then what I need to do is work that out. And I've got this already, and I can get this, take this away from this, and I should have exactly 12. So I will need to show my working. So I'm going to write that down over here. So that's exactly 12 will be those that are less than 12 and those that are less than 11, take those two things away. So I'm going to use my calculator to do this. So let's get my calculator mode going. So change that to 12 this time. And I get 0.94197. Just try and put as many decimal places as you can. I'm going to do that, take away this. So I need to do that in calculator mode, of course. Mode 1. So I'll use the answer button. 0.869. And then I should get a nice answer for me. So that's 0.073. And I'll leave it at that, just because I don't want to create any rounding error. Oops, just that one away, 0.073. So again, try to be careful about rounding error. You might want to have written down that before you rounded it earlier. You can work it out again if you need to, but try to keep your answers within the margin of error so you're not making any mistakes, and that should be fine. Again, I would remind you, you can use the tables for this, but I just wanted to show you using the calculator in case, so you're well used to using the calculator today, as that is the point of the video. So where were we? Number 13, was it? No, number 14, I think. So yeah, so we're back up to here. Just go down a tad. There we go. And it was 0.073 I think we got, so that's correct. And then 0.869, you can see that's all calculated correctly. So we are fine on both those answers. I want to do one more question, which is question number 15. And then the rest you can do if you wish to. So let's just point that to one side, get rid of that. And number 15 we're going to do. So number 15, first of all, we're going to work our way through that. So it says an archer hits the bullseye with probability 0.6, and it's asking for, she shoots 20 arrows at a time. The probability she hits the bullseye with at least 50% of her arrows. So again, what's interesting about this question is it doesn't say this is a binomial distribution question. So again, you do have to do a little bit of, is this a binomial distribution? So those classic tests, fixed probability, independent events, fixed number of trials, the probability doesn't change. It is a discrete random variable and it is binomial, so absolutely fulfills all the conditions from the previous video. So we're going to model it as a binomial distribution, 20 arrows at a time, and then the probability of success 0.6. And again, we're being asked for probability she hits the bullseye with at least 50% of her arrows. So she's going to have to get it more than 50% of the time. She needs to hit it 10 times or more, doesn't she? So we've got to think about how you work out the probability of it being 10 times or more. Well, that's going to be 1 minus the probability of it being 9 times or less. So again, we're going to use our calculator to work that out. I believe this might be in the tables, but if it's not, you can always use the calculator to work it out. Again, the whole point of this video is to show the use of the calculator, so I'm going to use the calculator to do this. So again, our old friend, mode 7, and we're going to work our way through. You know this by now. We're going to look at 9, 20 trials, probability of success 0.6, press the equal sign, 0.12752. We're going to go into calculate mode, 1 minus answer, and that gives me my answer, and it's 0.872, and that's fine. Next, we're going to look at part B. Quite interesting question. This part B says, find the probability that she hits the bullseye with at least 50% of her arrows in 7 of 12 sets, because this time she's talking about 12 sets. So if I just clear my annotations, we're going to remember that probability, 0.872. We're going to look at this now as another set of another binomial distribution, because again, it is a binomial distribution that we're modeling here. I just need to get my pen up. Apologies. So here we go. It's going to be a binomial distribution again, but this time we're talking about the sets of arrows as being my number of trials, and the probability of success, probability of 50%, will be that previous answer, the answer from the previous question. So 0.8725. And we're being asked for the probability she hits 50% of her arrows in 7 of the 12 sets. So we're being asked for 7 of 12 sets. We have to think about how you get that. So that's going to be, well, 12 choose 7. And then the probability of success, 0.8725 to the power of 7. And then again, multiply by the failure. So 0.1275 to the power of 5. Okay. And that's going to give you a value. And if you use your calculator buttons and work them all out, again, I'll just show you real quick how to do that. I did show it in the previous video, but I'll show you again. You will need calculate mode for this. So it's 12. And then shift the choose button. Be handy to use some brackets here. So 0.8725 power of 7. And then this is the power 5. I reminded you in the previous episode that these powers should always add up to that. So 7 plus 5 makes 12. Always a good check. And you're going to get this value 0.0103. So let's just shift the calculator off. Have a look at the answers. 0.0103. Clear my annotations. Just have a look. So So here we go, 0.8725 was the previous answer, and then 0.0103, you can see that happening there. So those two questions are interlinked. And so part C, find the probability she hits the bullseye at least 50% of her arrows in fewer than 6 sets. This is linked to this question again, but it's fewer than 6. So a reminder that fewer than 6 doesn't include 6. That's going to be the probability of it being less than or equal to 5. And this is where the calculator is really useful, because again, we won't have a nice table that we can look this up in, but we can use the calculator to work this out. So we're going to go into our friend mode 7 again and go through the process and just work it out from this particular variable. But this time we're going to use our variables that we know. So x is 5. The number of trials is 12. And the probability here of success was 0.8725, that value we calculated earlier. Press equals, and that gives us the value that we got. So 0.002407, and that will do. Let's just double check the answer. Clear my annotations. And you can see that happening here, 0.002407. Success. So there we are. That was the end of the binomial cumulative distribution function video for today. That's using a calculator to do binomial distribution function. I hope you've had a good experience of that and you're able to do that now at home. There's plenty of questions within MEX exercise 6 to try. This particular exercise is on page 95 and 96 of the textbook, so I would encourage you to get on and have a look at those. My next video will be on statistical testing. We do see binomial distribution function again inside of that, but for now these A-level videos on binomial distribution function in itself, this is the last one, so I would encourage you to work your way through the exercise and make sure you've got it completely finished so that we're ready for statistical testing next time out. That said, I hope you had a good week and that you will have a good remainder of the week, and I look forward to seeing you soon. Thank you for tuning in. Please do subscribe or leave a like, that would help me out a ton, and I look forward to seeing you soon. Goodbye.